Mr. Gordon here. So you should have this handout that I collected from yesterday and then Mr. Green gave you back today, talking about radian measurement. So if you remember the exploration we did yesterday, we looked at, okay, so if I have this radius of a circle and this arc, and they're both the same, so R1 and R1, then this angle here we called 1 radian because its arc was 1 radius long. We saw the same thing for the second circle. So this radius, why is it so small? This radius was R2, and this arc was the same length, R2, meaning the angle was still 1 radian. And then same thing for the third circle. This radius was R3, this arc was the length of R3, so again the angle is 1 radian. So a central angle in a circle that intercepts an arc that's 1 radius long is called 1 radian. And you'll remember we talked about the fact that 1 radian, when we measured it, it turned out to be 57.3 degrees, if we could be super precise. And that was because of the fact that Alex shared that it took 2 pi radiuses to get around the circle, which was about 6.28 pieces of string, radius long strings to get around the circle. So we know it's 2 pi radians all the way around the circle. We also know in degrees it's 360 degrees. So this is a key fact that we're going to use for the entire investigation today to convert between radians to degrees and degrees to radians. But first, let's get a deeper understanding of what a radian is. So if I have a 15 centimeter arc on a central angle, and the radius is 15 centimeters, well, how many radians is the angle? Well, it's 1 radian because the arc is 1 radius long. It asks for a degree measure, so that would be 57.3 degrees. So 1c says suppose a center with a circle O has radius r. What would you expect the degree measure of angle AOB, a central angle, if arc AB is r units long? Well, again, that's 1 radian, which is 57.3 degrees. And you can see 1c expressed in this picture here. Central angle, the arc is a radius long, so the angle is 1 radian right here. Measure of angle AOB is 1 radian. Now, question, I want you guys to pause the video, try problem 2, and then when you're ready, restart the video to go over it. All right, so problem 2, circle with a radius of 5 centimeters. So let me just draw a picture for A. So radius is 5 centimeters, arc is 10 centimeters. How many radiuses long is that arc? It's 2 radiuses long, so that means the angle is 2 radians. So in 2b, I don't even need to draw a picture. The radius is 8, the arc is 24, so the arc is 3 radiuses long, which means that central angle will be 3 radians. So hopefully you get the idea there. However many radiuses long the arc is, the central angle of the circle is that many radians in measurement. All right, so number 3, you got 2 people, 2 students, Khadija and JC. They're giving you 2 methods for being able to convert between radians and degrees and radians. And so I'd like you guys to pause the video, read over their methods, and try parts A, B, and C. And then replay the video when you're ready to keep going. All right, so you paused the video and you tried parts A, B, and C. And yeah, you're ready to rock. So Khadija's method to find a radian measure of 30 degrees. So you can see in Khadija's method, she takes the fraction of the circle that the degrees is, kind of like what we've done with arc length and sector area, and then she multiplies by 2 pi because she knows there's 2 pi radians in a whole circle. So for 30 degrees, she would do 30 out of 360, which is 1/12, and she'd multiply that times 2 pi. And she'd get 2 pi over 12, which we can simplify to 1 pi, whoa, 1 pi over 6, which I just write as pi over 6 because the 1 is implied. There's a 1 there. We don't need to write it. And that's how Khadija would do it. Now, JC, on the other hand, she would take, she uses the fact that 1 degree is equal to pi over 180 radians. She's just taking the original equation and dividing both sides by 360. And 2 pi over 360 simplifies to pi over 180. So JC would just take 30 degrees and multiply by this pi over 180 unit conversion that she's got. So she'd get 30 pi over 180. Then it's just a matter of simplifying fractions. What does 30 over 180 simplify to? Well, it simplifies to 3 over 18, which simplifies to 1 over 6. So again, it's pi over 6. Now this question C, Khadijah's method or JC's method, is a personal choice question. You can prefer whichever one you prefer. So using whichever one you prefer, I want you to go on to part A and try those problems. All right, so in part A, oh yeah, pause the video, try these before you watch this. So if you're watching this, I'm assuming that you've already tried part A, just part A. So let's start with Khadijah's method for 90 degrees. So 90 degrees out of 360 is 1/4. If I multiply 1/4 by 2 pi, I get 2 pi over 4, which simplifies to pi over 2. So 90 degrees is pi over 2 radians. And then I'm going to use Khadijah's method again for part 3. So 75 degrees out of 360. Well, that simplifies to, so 75 divided by 15 is 5, and 360 divided by 15 is 24. So that would be 5 over 24ths times 2 pi, which gives me 10 pi over 24, which simplifies to 5 pi over 12. So that's Khadijah's method. If you prefer to use JC's method, I'm going to do the other two by JC's method. All right, so JC's method, I would take 150 degrees for number 2, multiply by pi over 180, so I'd get 150 pi over 180, which simplifies to 15 pi over 18, which simplifies to 5 pi over 6. And then for 210 degrees, I would multiply 210 times pi over 180. And so I'd get 210 pi over 180, which simplifies to 21 pi over 18, which simplifies to 7 pi over 6. Cool. So now we want to talk about in part B, how do we convert from radians to degrees? So you can use either method, you just kind of reverse the thinking. It turns out to be a little harder with Khadijah's method because you get fractions on top of fractions, because a lot of radians are given as fractions, as you see all 4 of these are. So that method isn't necessarily the easiest. So I prefer to use JC's method when going the other direction and converting from radians to degrees. So again, JC's method, we're taking the fact that we know that 360 degrees equals 2 pi radians. So she solved for 1 degree. This time let's solve for 1 radian. Divide both sides by 2 pi. And so I get that 1 radian equals 180 over pi degrees. So to convert from radians to degrees, I just have to multiply by 180 over pi. So I'm going to zoom in for these. Just multiply by 180 over pi. So when I do that, pi's cancel out. 180 divided by 3 is 60 degrees. 5 pi over 4, I multiply by 180 over pi. Again, the pi's cancel out. And I have 5 times 180 divided by 4. 5 times 180 is 900. like you've seen the snowboarders do in the Winter Olympics, divided by 4 is 225. So that's 225 degrees. And then pi over 5 multiplied by 180 over pi. This one's a little easier. Pi's cancel out. And 180 divided by 5 is 36 degrees. And then last one multiplied by 180 over pi. So the pi's cancel out. 180 over 6 could simplify to um, 30 over 1, and then 11 times 30 is 330 degrees. So using these 8 values that we got, you want to begin to fill in this table, and then using the values that you fill in, you should be able to fill in the blanks that remain. So pause the video and do that. All right, so you've already filled in this table. Now I'm going to show you the solutions um, from when I already tried to make this video and lost it all. And so you can see um, here's your solutions for the table. And you can just check yourself. Pause the video and check yourself. All right, so let's go on to the lesson summary. So if you'll pause the video, try the lesson summary, and then watch the video to recap the lesson summary. Um, okay, you pause the video, you try the lesson summary, let's recap. So how to draw an angle that measures 1 radian. In a circle, you draw a central angle with an arc that is 1 radius long. The key relationship is that 2 pi radians is 360 degrees is 1 revolution all the way around a circle. Everything we do is based on that. So you can see in part C, this is the crux of what we've done. So this formula here, d over 360 times 2 pi, that's Khadijah's formula to convert from radians to degrees. And this is JC's formula to convert from radians to degrees. In part 3, this is JC's formula to convert from degrees to radians. And that's the key. Now, for part 2, r is a function of v. If you look at these 3 where I've drawn green arrows, you can see as I go from radians to revolutions, 7 pi over 6 to 7 over 12, 3 pi over 2 to 3 over 4, 5 pi over 3 to 5 over 6, the pi goes away and the denominator gets twice as big. So to do that, I would just multiply the r as a function of v. Okay, sorry. I got these backwards. So r as a function of v, that's just saying how many radians, how do you convert from revolutions to radians? So let's actually figure out v as a function of r, which is what I've shown with the green arrows. So v as a function of r, I said you have to take the radians and make the pi go away, which means the pi is in the denominator, and make the denominator get twice as big, which means there's a 2 in the denominator. So if I wanted v as a function of r, I just switch that formula, or r as a function of v, I mean, the radians as a function of the revolutions, I would just solve that formula there. So r would equal, multiply both sides by 2 pi over 1, r would equal 2 pi v, which is basically your circumference formula. And don't worry about part D. All right, thanks for watching the video. Next up, you should be doing this Khan Academy assignment, radians to degrees, and then begin on this radians homework, which you can use your table to help you with. So 2 more things you got to do. Thanks for watching the video. Hope you guys have a great day. See you Monday.